here we go, y'all. We're going right to it. Mic is on. Oh, yeah, because we have time for this. All right. So, that phone, is it on the screen? Why is it like this? Just fix it, Nate. Or Mr. All right. So, all right. What's my domain of a normal log? X has to be greater than 0, right? Because we have a vertical asymptote at x equals 0, right? So my normal domain is x is greater than or equal to 0. Can we take log of a negative number? No. Can we take log of a 0? No. So, because of that, whenever I see a problem like this to find my domain, I set the part in parentheses greater than 0, right? It can't be equal to, it can't be, and so last time I showed you how to do this wrong, and I told you guys to test point it, but there's no video evidence of that, so who knows what I taught you? What thing? What are you talking about? This freaked me out at first. I'm like, who is that person? Here's what I'm going to show you guys. How do I know when this is positive without a calculator? So what I could do is set, when is each piece greater than 0, right? So when 1 is greater than x, it's positive, correct? So when x is less than 1, it's positive, right? Because when I'm greater than 0, I'm positive. Ask me if I'm sure. I'm positive. All right. Hey, yo. So when x is greater than 1 on this one, I am, negative 1, I am positive. Wait, oopsie. Do you guys see what I did here? I subtracted the 1 over. Yes. I added the x over. So, what do I care about? Think about this. When x is greater than 1, I'm positive. When x is greater than that, I'm positive. But, hold on. Yeah. This, when 1 is greater than x, when x is less than 1, they're commutative. You can say it either way, because they're the same thing. Oh, well, I don't know what I said. So think about this. When do these overlap when they're both positive? When x is less than 1 and greater than negative 1. What's a positive divided by a positive? So what's my domain? From negative 1 to 1. Now, are you guys going to see a lot of problems like this you have to do longhand? No. But are you going to see a lot of problems like this? Yeah. Yes. What do you do with the thing in parentheses? Greater than or equal to 0. And that will give you the domain. If you can do this one, you're in really good shape. But just know the process, right? Domain is set the inside greater than or equal to 0. Just like, remember domain of a square root, we set greater than or equal to 0. Domain of a rational, we set the bottom equal to 0 for when it can't be. Does that make sense? So we care about when that's 0. All right, we're already behind, but that's fine. I got nothing but time. I didn't mean to rhyme. This marker erases really poorly. Oh my gosh, this is the worst. This is the most work I've done in years. All right, next example. The next one's wild and great. All right, look at this beast. It left black smudges everywhere. All right. So, match the graphs with the function. This is two. So remember, that marker's definitely not dark enough to do this job. What's my normal log function look like? That's a log with where my base is what? Greater than 1, right? So right away, when I look at this one, which one does it have to be? C. So that one's done. All right. Now, next question. What's this negative x do to it? Flips it over what? The y-axis, so that means it has to be A. Okay. And what's this negative in front do? Flip it over the... Flips over the y, or the x-axis, flips your y over the x-axis. Which one flips it over? No, it's B, guys. You guys got me in my own head. Because look at, if I flip it, you know what I mean, just flip it over, right? And now, why is this one like this? If my log base b of x, if b is less than 1 and greater than 0, of course, I know that the original graph looks like this, right? It's flipped to this. So when I flip it over this, I get D. Okay. That's not so bad, right? Just memorize this. Okay, based on your I just told it to you. Based on your findings, which one of these three could also be log of 1/2 of x? B. These two equations are actually the same thing, because what's 2 to a negative? Like, think about your negative powers. You flip it, right? These are the same graph. I can't believe I wanted this long. All right, that was fun while it lasted. Show the fade. All right. I had this on under that other thing. Oh, I tried to erase that graph. All right. I tried to erase that graph too. I don't draw the graphs that well. This marker doesn't erase either. My board's getting all dirty. All right, sketch the graph. Do it. All right, let's do it. Let's get right to it. I don't know what I have my board, but it's working worse and worse. All right. I'm going to go pretty quick on this one, okay? So we're doing log base 2 of x, right? And that equals what? So if I plug in 1 for my x, what's log base 2 of 2 to what power equals 1? 0, right? So then the next one, say 2 to what power equals 2? 2 to what power equals 4? 2 to what power equals 8? It's the opposite of an exponential, right? It's saying 2 to what power equals 1, 2 to what power. If I flip these, it would be an exponential, right? If I flip my x and y. Sorry, I'm doing this pretty quick. So I have, 1, 0. I know that. 2, 1. 4, 2. 8, 3. Because what's this look like? An exponential. All right. Now, how, if I were to graph it like this, what would that do to it? It flips it, reflects over x. So what happens to all my y values? They switch. So I'm going to write that to help me out with my pea-sized brain. So it'd be -0, -1, -2, -3, right? -0 is just 0, right? So if I were to graph that, you just take each point and I reverse. I want to see if I can draw this smooth, actually. That's not bad. So this is negative log base 2 of x, right? That's actually... It's like it's 2... It's... Think about it as 2 to the y equals x. Yeah, for like, it's your base... I'll just write log b of x equals y. It's b to the y equals x. Yeah, this comes up a lot. Yes. If you don't have a calculator. All right. So hot. All right, so g, this is my g of x, right? Oh, never mind. I could just wrote it over here. So my g of x is 1, 2, 4, 8, 0, negative 1, negative 2, negative 3. I just jumped the gun on that one. So can I make a rule for this? What does x go to from here to here? Does it change? What's y go to? And we've talked about that, right? Holy smokes, I'm itchy now. That dandruff life. That's kind of gross. Don't just disregard that. All right, if I scroll down, can we still look at this graph? Probably. Let's answer questions about it. What would we do if we just had infinite time to learn this stuff? Wouldn't that be fun? What? This is the most exciting day I've had. All right. So what's my, let's analyze these. This is the money step. So f of x. So when I look at f of x, what's my domain? 0 to infinity. What's my range? Negative, all real numbers, negative infinity to infinity. What is my concavity? It is concave. Oh, it's the green one. I messed up. So that'd be concave down. And if you're concave down, what's that mean about your rate of change? Increasing. Because remember, this is super negative and this is less negative, right? So you're increasing. Oh, wait, no, you guys said, no, guys, I said it right. It's decreasing. Guys, I'm keep looking at the blue one. Because think about this. What's my slope here? It's like what? 2? And what's my slope here? So what's happening to my slope? It's decreasing. Concave down, decreasing. Concave up, increasing. And do I have a vertical asymptote? Yeah, x equals 0. Yep, that's your basic one. We didn't shift it, right? All right. What about my g of x? How are they the same? How are they different? What's my domain on this one? It's a nice ruler view. It's still 0 to infinity, right? It's not the inverse. We've been doing that a lot. These aren't inverses. They are flipped. What's my range? It's still negative infinity to infinity. But what happened to my concavity? Yeah, this one's concave down. Because what's happening to my rate of change? Ah, Jiminy Crickets. It's concave up because what's happening to my rate of... It is increasing. So g of x is this one, right? So right here, my slope is like negative 8. And right here, my slope is like negative 1. Negative 1 is bigger than negative 8, right? Yep. Did you guys realize how much graph analysis you do?
I know.
Look at this. Are we going to do it, guys? We are.
We are.
Absolutely not. All right, let's look at end behaviors. No, you don't. You love them. This is your, make it your favorite. Oh, how many graphs do I have to sketch? What is going on with my board today? Is it too cold up here? It's not erasing. What, erasing a board?
No, making that thing right there.
Oh. All right. All I want to do is give the function, determine the asymptotes and end behaviors. That's all I care about right now. Now, what's going to help me is if I graph my normal, you know what I mean, asymptote x equals 0, and I'll use that to graph these. So what's the minus 1 going to do? Right 1, right? So what's my asymptote? Is my VA, right? So what's my limit as x goes to infinity? Infinity. What's my limit as x approaches 1 from the positive side? Infinity, right? I did that pretty quick. Remember, we use the asymptote for our left hand as we come from the left. Your left hand, that's called left hand notate. Now they know your name and which hand you use. Someone once told me to Jiminy Crickets. To rewrite that like that, right? So, what do I do? What am I going to do with my vertical asymptote? Where's it going to be at? So you want to move it? All right, I'm going to move it left 2 to negative 2. And then what's that negative do? What's it do? Yep, so it puts it at 2. But now is my graph going to be on the left side of it or the right side of it? Left side of it. Why is it on the left side? Because I flip it. So I went left 2, I flipped it.
Oh, yeah.
Yep. Slide divide. What?
That just makes answer to everything.
So now I have an asymptote. My asymptote's at x equals 2. What's my limit as x approaches 2 from the negative side? Negative infinity. And what's my limit as x approaches negative infinity? So I have to change my limit notation now because I am... Yeah. For logs, they should be 1 negative, 1 positive. Because its range is negative infinity to infinity. So yes. Yeah, astute observation, young sir.
I just instead of doing moving it, I just think of it as plug into what that's where the asymptote is.
Yes.
Okay.
Do you guys understand what he just did? He's thinking, when is negative x plus 2 equal to 0? What? X, you did negative x equals negative 2, so x equals 2. Will that work every time? Yeah. Like this one right away, what's my vertical asymptote going to be? It's the same thing we did with the denominators of rational functions. What's up? That's what I'm doing.
What does that do?
I'm going to do it. I'm going to do it. So right away, I know I'm going to have my asymptote at negative 4, right? What's the 2 going to do? Move it up 2, right? Now that, moving it up 2, does that affect our vertical asymptote at all? So I don't care. Because this is a question asking about anything with it. So the 2 is going to move it up 2. That's cool. But what's that negative do? it flips it. So it's going to look like that, right? It's in front. Yeah, yep. So now that changes our positive and negative infinity though, so it matters. Okay? So I do my limit as x goes to infinity. As I go to infinity now, where's it going? Down to negative infinity. What's my limit as x approaches negative 4 from the positive side? So as I come from, yep. Remember, these should never be the same answer for both, as a wise person once said in this room. This negative. There's a negative in front, so you have to flip it. It doesn't. I was just sketching it. If you, do you want a better drawing, it would actually go through like that, because that's go up too. But we don't. This doesn't matter. We just, the question was asking for these three things. So I'm just drawing quick sketches. I'm not being accurate. Story of my life. All right. What's that minus 3 do to our graph? Does it affect anything else? Does it affect our asymptote? No. Does it affect our limits? Nope. So we're going to do, this is just good old-fashioned fun. This is our good old... It's just like this one, but we had to change. We're approaching 0 instead of 1. I should post the answers. I'll take you on in a one-on-one basketball game for all the quiz answers. If I lose, you don't get them.
I don't know.
Did you hear that though? If I lose, or no, if I lose, you guys don't get them. If I win, you guys do get the quiz answers. So I get to humiliate you in front of the entire student body, and you have to let me win. You have to make it look like you're trying. And it has to be embarrassing.
Just let you drop.
Yeah, let me steal it and trash talk. I bet you I could get under your skin enough where you would try. All right, let's take a look at this one. How do you guys feel about that example? Okay. If you had a calculator, it'd be really easy. This one, let's change your life a little bit more. Oh, I love these problems. I don't know what happened there. This is my favorite. All right. Oh, never mind. This isn't what I want. Ah, mamma mia. All right, can I plug this in? I'm just going to graph it. Can I just graph this and see what's happening? All right, 1, negative 2.6. Or 2.86, so like that. 2, 0. 6, 1. 20, whatever. Does that give me an idea of what this graph is going to look like? Okay. So, is the function increasing or decreasing? Why did you do that? All right, is it constantly increasing or decreasing? Not the rate of change. Is the function going up or going down? So the function's increasing, not the rate of change. It's increasing it's going up the whole time, slowly and surely. Is it concave up or down? Which means what about it? What's it mean to be concave down? The rate of change is decreasing. So if I take the slope, why do I keep doing this stuff to you guys? Is because it's from unit 1, and I want to make sure when we see it again, it's not like new to us. Does that make sense? So my slope here is bigger than my slope here. I'm sorry, my slope here is big. Yeah, my slope here is bigger than my slope here. But the function's still going up. It's just the rate of change is slowing down, right? And what's my domain? Does it want domain? Yes. Can I determine domain? Yeah. Yep. Wait. No. No, it's not. Because I didn't draw it right.
Oh,
Yeah. Why am I saying I can't go to 0? When I get close to 1, that got really negative really quick, right? I'm trying to think if there's another way you can ensure that you get it. What's my point right here? What's it normally? So what happened? Okay. Look at us go. Now, how do I know this is log and non-exponential? Which number is getting bigger faster? My x. So as I plug in huge numbers for x, my y doesn't get much bigger. That's a log. If this is switched, it's a exponential. There's some homework problems like that. Yep. Everything we're learning about logs is true in reverse for exponentials. And everything we learn about exponentials is true in reverse for logs. So this one, let's say I had a homework question, which you guys do. Is it exponential or is it a log? My x gets huge, but my y doesn't. That's a log. If it's reverse, it's an exponential. Okay? So I have the point, let's graph these. Negative 1.9, 2, 2.1. All right. What happened to my intercept here? It went left how many? 2, right? It went 1, 2. So what's going to happen to my asymptote? It's going to be negative 2 because I need to go left 2. Perfect. It's like a good sledding hill. We don't have time, Mr. Twilliger. All right. That's a snowman sledding. It's Clark Griswold sledding.
oh, it's on the side.
Yeah, it's going down the hill. Because it's concave up. All right, so is this decreasing or increasing? Decreasing like my salary? It should. All right, so what happens as, what's my concavity? Concave up. ROC is increasing because it's getting less negative, right? And do I know the domain? There you go. That's not so bad. Guys, we're going to do it. No, I don't. I got 7 minutes. Oh, geez. We can do it. Worst case scenario, you're on your own.
That is the worst. That always happens.
No, it doesn't. It happened one time. All right. So, read it. Calculator question. How do I get my t's for this? What do I do? Plug it in. When you plug it in, you get 0. 11.09. 22.18. 28.67. 33.27. 36.84. Ta-da. See? Now, our old equations were I plug in time, I get out money, right? Or get out how long. This one is K equals how many times your amount there is, right? This is 1 times 0. You have your initial amount when you have 0 time. Make sense? What's the 2 mean then? How much is it? If I had $10 in there, how much money do I have now? 20. So what's my doubling time? Do you see how we could, you know how we used to have to graph them and do second, equal, and like go through and figure it out? By using logs, could we find a doubling time much easier and quicker?
Yeah.
Ah. Because you see how we got doubling time so quick, we didn't need to graph or anything. Well, we had to plug it into that equation. What? Actually, I don't know.
Did that make sense?
Your graph looks like this. It's you graph in your calculator. I don't want to spend time on it. I do want to talk about this one though. So we got 11.09 years, right? So based on that, if I taken $1,000, if I had $1,000, that's an old song. What should I plug into T? What I get up above to double it? All right, I'm gonna plug this in my calculator. And what should I get? Guess what I do get? 1999.96. Why isn't this the exact same as 2000? What? Yeah, I had to round, right? Rounding makes a 4-cent difference. This is how Robinhood makes their money, right? Every time you trade, they take fractions of your pennies. Robinhood, like, do you know how Robinhood lets you buy and sell stocks for free? Well, most, like, you had to pay $8 per trade. What they do is if you make $360 and 2,318 cents, they take that every transaction.
So they make less than a cent.
But when you're making, like, I think when I looked at last year, I made something like 60 trades. And if they have millions of users and I'm trading small amounts of money and some people are trading like millions, and they also do brokerage accounts, they make money.
That's why they still exist.
Yeah. Robinhood does make me nervous. No, Robinhood is by yourself. Your homework is do all the practice, but tomorrow I'm giving you a work day to work on it and ask questions. No video. Tomorrow's finished we're going to work on 211 to get it done. But if I were you, I'd get a head start on it because we know how it is. Do the intro ones. Just do the ones you can, look through them. Spend like 20, 30 minutes on it.
No, man, look. Realize I can't do anything? Yeah, but I put it back there.
What? Oh, geez. Bye, everybody. Have a good life.